Welcome. This is the third installment of our little SSB things with Go kind of tour and walkthrough pattern thing. And for today, we're gonna focus on some deeper database stuff. We're gonna talk and show and walk through the Go implementation of Flume, or starting with some aspects of it. And the first thing we're gonna talk about is this concept of the basic file storage format, which is what came to be known as an offset file. An offset file is basically one giant file with sequenced entries. So you can say, give me entry number 25 or whichever number, and they are basically appended to the back. So these are basically append-only files in a sense.
I think one thing that took me such a long time to realize with offset.log was like that it contains all of the entries for all of the feeds that you follow, instead of it being like one file for each feed that you have. And I'm like, where's my file for my feed?
Yeah,
it's just like this jumble of everything.
I mean, that is of course a decision by the higher level implementation of what you're going to do. I mean, could have different cases for you need to store this there. And right later, then you realize the single things by indexes on top of these files, but that's definitely for another day, I think. Right. So let's jump into it. So first, we're going to look at the Margaret implementation. Margaret.
So I know why it's called Margaret, but why is it called Margaret?
It's called Margaret because it's the log lady, and the log lady is the name giver for this was Kix, and I'm not sure if you can find it that quickly. Yeah, it's a Twin Peaks reference, and in Twin Peaks there is this person, which is the log lady, and of course because you call these logs, and she always has a log, Margaret is the log lady. So I think I can't go deeper on this explanation.
No, that's perfect. I just thought it was good to have for posterity.
I mean, everybody gets confused about this. I would have been perfectly fine if we called this Go Flume or whatever.
Yeah.
But
I mean, I think my biggest concern is that you have no common naming aesthetic. It's like Margaret and then you have Luigi, and it's like, come on, 2 different worlds.
Yes.
Should be Mario and Luigi. I don't know.
It wasn't Mario first.
It was. Oh shit.
Supposed to do it better, but yeah, it doesn't help. Kicks at his names. It's a base of its own.
Yeah, no, it's great.
Okay, so jumping into a fresh terminal here, going to the checkout I already have.
Boost the font maybe 3 times.
Pushing now. Okay. Also opening my editor, which comes with an old session that goes somewhere else. Bye. So let's see how we do this. I need to make this bigger too.
What is this to begin with? It's just looking at Margaret's structure?
Yes. Wait a second, I'm seeing that always good when you plug the power charger into the thing.
It is good, actually.
Yes. Cling, it's happy now. Good. What is this? What's your question?
Yeah, I mean, what are we going to do now? We're just going to look at the structure of Margaret.
Yeah, we're going to try to briefly walk through the repository structure, what's there and why, and what will probably be deprecated maybe at some point. So let's maybe start with log.go. Log.go has the central interface in it. And some errors, but we can, out of bounds, if you try to get, if the fset entry has 5 entries and then you try to get entry 6, you get the out of bounds error, for instance.
Okay.
But yeah, the most important, the methods of the interface is you can get the sequence, you can get an entry by sequence, you can create a query, and you can append entries to it.
A sequence is an observable that holds the current sequence number.
Yes, an observable is a thing where you can either get the current value or you can get notified when the value changes.
Okay.
I would like to have the method here to get the sequence directly, because right now you always have to get it out of the observable, which is a bit of a, like you have to jump through the hoop of calling value and then unpacking the value. One thing here, I should probably link later to my post on SSB where I talk about why empty interfaces are terrible. But this is the way, I mean, we were young gophers and this is the way we got it working, and it kind of fits together, but you will later see why this is a bit of a headache.
Just like, I don't know what I'm getting back.
Yes, exactly.
Where do I find it?
Yeah.
So like, I don't get why it's returning a sequence. I mean, or why it's, what does a sequence mean in this sense? It's like a post object or the entire wrapper of that.
Which one? This? No.
Yeah, like this get sequence or whatever. I don't know. I mean, one thing that I don't understand is why would it change? Like the observable can change. Like, yeah, that part. I don't really.
Yeah. Okay. What you can basically do is you open on one place you are appending to it, and you don't want to poll for the changes. You want to be notified once something is appended.
Okay.
So what's happening?
So basically, a seeker is just like sequence is just like, okay, whenever we change the kind of the cursor inside the log, that will be notified. That will have the latest cursor in a way. No.
Well, I think you can say it like that, but it's not like a file handler that you seek around. It's just the latest sequence number.
Okay.
But yeah, how this is used basically is that you have one writer thing, and then you have like multiple indexes that want to do something once there are new entries. And so this is basically how you can realize this. Yes. Let's see, what is this for? Oh yeah, this is just checking for the test. Yeah, sequence itself is also an interface. This was another error. This might also turn into I think we just chatted about this on another occasion, but some parts of go-ssb are definitely to learn from. So like this could be improved probably, and this is one of them, since we always work just with flat sequences basically. Like there's just a number inside, there's not layers of them or whatever that makes any kind of sense. So this was definitely an error that we should have.
What's the error here? That it's a method, or?
Yeah, that it's an interface type of which you call the method sequence again to get then the integer value out of,
instead of just using, like, for example, base sequence.
Yes.
To start with,
Yes. Yeah. So here, this one and this one.
So it's called sequence.sequence to get the sequence.
Yeah. And this could also be, you could kind of like a observe method and get the observable, and also a sequence method to just get the integer type directly. Okay. This is errata for Margaret 2 or whatever. I'm wondering.
Margaret
one cool
2.
thing.
Is that the current version?
No, we are still in 0 land, so we can break everything and just make a version 1.
Oh, okay, nice.
Yeah. Yes, I think next we just walk quickly through the code, through the test structure, because then I think will make some sense later.
Yeah. Okay.
So in the test folder, let's start with simple, because that's obviously the most simple.
I was like, simple. I like the sound of that.
So this comes back to. So of course you see it's very simple. So we have a test case.
That's a bit blurry, but.
Let's see. Should I make it bigger?
Yeah, maybe that'll help. And then minimize the scrolling, I guess, for the encoder.
Slowly scroll down.
Yeah, exactly.
So what we see here on the top of it, it seems a bit daunting, I would say. We have test case struct definition with types and specs to query about, and results, and should it have an error or not. And then we have this make test function, which accepts a test case and returns a testing function, which is then later run. And the F here, but also I've seen that this already starts out with a function that takes a new log func and returns a test, basically.
Mm.
And so what this does is you pass it in a way to create a log.
Mm.
So a new log func returns a margaret log.
Oh, okay, yeah.
And
I was thinking of like console logging, but yeah, this is smart.
This is definitely a big gotcha. I should like what a log is in this case. Here we're always talking about these offset logs.
Mm-hmm. Yeah, no, it makes sense. It's just like
But not getting back
semantically satiated or something. Right.
Right. So here we call the f thing, which creates our new log, which we then work with. We have a small cleanup thing that later deletes the file.
So you create name. Like, why does it have a name?
The t.name is the name of the test.
Okay, but the log has a name as well since you pass it into f.
This one.
Yeah, I mean that's the same thing, I assume. Or, I mean, like
we will come
on
to this
line 37.
Line 37.
Yeah, you're creating a log with a name.
Yeah.
Okay.
I think we will see this in a minute.
Okay,
Yeah, the log, the new test log func accepts a name for more descriptive purposes, which will become apparent once we are below.
cool.
Two
Yeah, it's
scores.
just hard to know which parts I should ask about or not.
Yeah, it's fine. We can come back to this.
Okay.
So the first thing that happens, we should probably comment this.
Oh yes.
So this iterates over TC values. TC is the value of this test case struct, and the values are the ones that you basically put into the log. And then later, and then afterwards, the query uses the spec. So a query spec, I haven't said this yet. The query spec is a list of query arguments, like limit by 5 entries, or just give me entries later greater than like sequence 6 or whatever. We'll see those in a minute.
Does that have the same functional style that you've liked to use previously?
Yeah.
Cool.
Yeah. Similar, a bit different, but very similar. Yeah. Then this is just some boilerplate to empty the source. Source here is the query always returns a source thing, which you can iterate through.
The source thing is like the base log, or is
it's a Luigi source. So in Luigi we have sources and sinks. Sources you can read from, sinks you can write into.
Okay, yeah.
So once the boilerplate for emptying the source is created, so results here are stuff that gets returned from the source.
So this is like, it would be like calling source.drain or something?
Source.drain is basically what happens here.
Oh, okay.
And so the value that gets returned from the source is then checked if there's no errors to be expected, it gets unwrapped, and then we test the equality basically from the thing that we get out of the. Basically, do it like this. That's maybe a bit clearer. Which v is which, basically.
Oh god, yeah, I didn't notice that first.
And this then is
get got maybe.
Yeah, the names here are definitely not good.
Or could you just rename them all at the same time using it?
It would have been much better. Yeah, thank you. I should probably rename this one first, then I don't get into the replace madness.
Voila.
Much better. And if there is an error, then it breaks out of this loop. And so lastly, we check that if we have an error from the stream, it checks that it is the error that you want to see, basically. And then the last time we do another get, and that should return us an end of stream error.
Okay.
And if it's not that, then that's also.
And end of stream is a good error. It's like, yep.
Yeah, right. This is how a stream ends, basically. Yeah, exactly. So now we finally come to the definition of the test cases. And here you start to see what the names are for. So the name of the first test case is simple. We have no query spec in this first one. We just have 3 values, and we expect to get all of them out again. So then the second test case is reverse.
So spec are like opts in JavaScript land.
Opts, I guess so.
Yeah, I was just saying it for myself on the stream.
Yeah, cool. Yeah. Next is reverse. So this tests the Margaret reverse query option, basic query spec option. We put 1, 2, 3, 4, 5 in, and we expect them to get them out in reverse order.
Yeah, this looks nice.
Yeah, reverse false then is just for this is working as expected, that if you switch the reverse to false, it should still return the same thing. Now we get a bit more, not complicated, but the second query option we see is greater than GT. And greater than 0 then means that the first thing is yielded, or not returned again. We have greater than equal. We have smaller than, less than, and then less than 2, less equal 1.
Oh, wait, what? So less than 2 there? Is that working?
Oh, right.
Because it seems like that would be LTE.
You see this here? These are 0 indexed, which doesn't make it nicer in my book.
Okay, wait. So
This is the zeros entry. This is the first entry. This is the second entry.
Oh, fuck.
It's lighter than 2. That's 0, 1.
Yeah, okay. It's not the values. It's just the sequence number.
Yeah, these are for the sequence numbers, exactly.
Okay, yeah. Yeah, that's.
Could have done these with ABC, I guess. This would have made it a bit differently, maybe.
Yeah, I guess, or just 0 indexed.
Yeah. It's 0 index, 0 prefixed, right?
Yeah. No, I was thinking about the values, but again, then it's still a bit confusing. Yeah, I understand now. Cool.
And then the final thing we learn about is the limit, which is just after n entries it stops.
Makes sense.
And then to make sure if we fill in less stuff than we expect, basically, then we check basically that the end of stream error is returned as expected.
Okay. And then these other ones are like combinations that don't work as intended.
This one
looks like you've written something here.
Oh yeah, there is an issue with greater and smaller that it probably doesn't work as intended. Yeah. Another concept is that you can open these queries as live. What we call live is that the source might not have all the elements to fulfill the query yet. If you want to wait for entry number 6 and there are no 6 entries in it yet, if you do it without live, it will just close immediately, basically.
And is that unlimited? Is like it's a streaming kind of thing?
Yeah.
Cool.
Exactly. One final thing that you sometimes see in the indexing code, for instance, is that we have the concept of this sequence wrapping, basically.
Is the indexing code also in Margaret?
Yes, the multi-log code is in here.
Okay, cool.
This is definitely, we will not come to this today, but there's also another package called Librarian. And Librarian are the indexes on top of Margaret.
Okay.
But for some reason, I think we should merge this into, if we get around to a Margaret version 1, I would merge Librarian back into it, because we have another, kind of index, which we call multi-logs, which is logs inside logs. but that is in Margaret. And so to be more coherent, I would just merge librarian back into Margaret and make it one thing.
Okay.
But yeah, that's not most likely won't get there today, I think.
That's fine.
But for the iteration stuff, sometimes you want to see again which sequence is this entry belonging to, because if you when you process new entries, you might need to know which sequence number this entry belongs to. And so this is what you see here. If you turn on the sec wrapping option, then you get so wrap with sequence gets you the sequence and the value it belongs to. So number 1 is sequence number 0, so forth. Now, this is all the test cases that we, and now I showed you all the test cases, and then finally we have this small wrapper thing here, which now uses this make test function together with the TC name, and this makes all the tests run, basically. And then there's one more ad hoc thing which says that you can do live and reverse at the same time, but this is just because it doesn't fit so well into this other pattern. This is a one-off here, basically. Yeah, I mean, reverse and live doesn't make sense because when does the first...
Yeah, and I was like, wait, what?
Yeah, exactly. Right, so the naming question, right? This one, I'm not sure if I answered it.
Yeah, I was just thinking, like, yeah, it's nice for tests, but since it seemed to be something in Margaret, like, where does the naming come in to play?
It's not really in Margaret. It's let's go here. The new log func thing.
Yeah.
So we just walked through the simple test now.
Yeah.
And these log funcs. So where is this called? Yeah, this is Kix's go-style is very functional. So you have function definitions of function definitions that do other stuff. When you go to the tests, all folder and tests, then you have these imports here, and you have this thing here, and that goes somewhere else again. But this one, it's a bit back and forth, but what's basically happening is that you register a bunch of logs that can do tests, and they have a name.
Okay, so it's not a Margaret thing then?
No. The Margaret itself, the logs themselves, they don't have names. It's just that you want to know, for instance, we have a memory implementation, like an in-memory RAM implementation of logs. And I should probably do this here. If you run tests here, nothing happens. If you run tests here, stuff happens. And then you have the test with offset, and so the simple ones are here, for instance. And this does it with JSON, with message pack, with CBOR.
Oh wow, nice.
Yeah. Can do all this stuff. Wait a second.
Yeah, I was basically asking because, like, one of the kind of hypercore abstractions, hyperspace, I think has a name kind of thing going on where you can select feeds by name.
No.
And I've never really used that, but I was just curious if there was something similar here. But it's the testing.
These names are just for the tests themselves to, so that you can basically see which log implementation was tested.
So in this case, like message pack would be one of the names, or no? What's an example of one of the names? Is it just simple, or?
Here on the left side, these are just the...
Okay, so it's the entire path, kind of.
Yeah, it's the path of the test. So you have which test it is and all that.
All right, yeah. Cool. So it's just extra logging information. That makes sense.
Yeah. Yes. How all this is jumbled back together, or like, how to say? Right. For this to work, you need to import this thing here.
Oh, okay.
Then when you go into the test the implementation of the thing, we have another test here. Right, here it is. And this init function is then imported in the test, and this uses the test registry here to register the offset log with some kind of encoder thing. And yeah, this then uses the codecs together with these logs, and they are basically then referenced by name. So it's offset/2/cbor, offset/2, yeah. And you could have other codecs here and then just test all of them.
For example, like the flat file thing we're talking about maybe doing today.
Well, I would do the flat file thing as a totally different thing.
Oh, okay.
Because these offset things have the same kind of prefix delimited length thing going on that Dominic is also doing.
Oh, okay.
Yeah. Let's see what next.
So there's offset and offset 2, and offset is Dominic's, or offset 2 is the new goal. No.
Offset 1 is also different.
Okay.
Let me remember why we discarded this.
So offset is just like not anything that should be used.
No.
Okay.
Deprecation warning, please upgrade to offset 1. I think there was some issue with it that I don't even remember. Great. What's kind of nice about these tests, though, is that all these tests here are written against the interfaces. So we just looked at simple. Another one is concurrent, where one side fills the log and the other one reads from it.
Nice.
And get, again, I think get is also super okay. Some of these are very simple, but it's just the kind of thing.
The irony of simple being the not simple one.
Yeah, like you have all these boilerplate, and then you have exactly one test case.
Yeah.
Well.
I mean, I'm probably guilty of having done the same thing in the go-ssb room things. Like I was doing my taxes yesterday, and I ended up like writing a program so it would make it easier for me to do my taxes. So it's like you do some of that stuff, so it's fun to do the kind of boring stuff.
Yeah. Yeah, but this could probably have at least one other case with too short or too long values or results.
Yeah.
But yes, exactly.
Okay, so that's a test then.
That's a test then. I'm wondering if we should walk through. Let me think. I'm not sure I need to show you the memory implementation. That doesn't make that much sense. I was just wondering in my head, where should we go next?
Show me whatever the bare minimum I need to actually get started to use it. And then from there, I'll probably discover things I don't understand yet. If that makes sense. Otherwise, take some other route.
Let's see. I think we should just let's do the flat file thing together.
Cool. Yeah.
So I make a new folder here. Not here. Flat log.
Nice.
I'm also bad with names. So, and to kickstart these processes, I will basically just copy this approach here, but we don't have a codec in that case, so we just register one function basically. So let's see. These are for the other thing. Okay, we just basically need, whatever. Make a test folder in flatlog, copy that file there. And then we rip out all these codec stuff because we don't need it. We rip out this. There's most likely nothing left at the end of this.
All the imports.
Yeah, and the flat log will also have no codec because we just write. Yeah, I think this is fine, most likely. Fix this import there. And we don't have codecs. So what's basically happening here is that it can do.
And you're also thinking of like the flat log is 1 log per feed, and each line is 1 entry.
Yeah. Well, feeds don't come into any of this yet, right? So this is a totally abstract store. This one per feed thing would happen in the go-ssb implementation.
Okay. So we just register, okay, so this one just takes a stream of messages and just puts them in.
Yeah, writes them to disk, yeah.
Cool.
So we now need the open method. And this will most likely complain. What we can start doing now is we go to our new flatlog package and the test folder there. Yeah, okay. We'll now start to see errors. So this is the path it wants. And it's supposed to return a margaret thing. Oops. I need to make this type real quick. Oops. Yeah, okay, now we start to see the errors that flatlog doesn't implement the log yet.
What is that magic command?
Impl is a very nice tool. Oh yeah, okay, now I need to double check where it is.
Yeah, let's write that down in the notes here.
Yeah, I will get the link to where it is.
So looking at interfaces.
I think it's
kind of like looking at the .h file in C, or?
Yeah, let me see. I think it's in from Dominic Honer's tools.
A new person as well. Someone who does a lot of Go stuff, or?
Someone who does a lot of Go stuff. Who's the Emacs person here? Yeah. These ones. These lists, I will just put this list there, but
cool.
Impl is down here. And yeah, it's from somebody else, but yeah, it base. Yeah, whatever. This works. It's not just the tools list here, it's a bunch of other stuff too, but yeah. So let's see if this has a good README. Yeah. For instance, if you're writing a new file for whatever reason, it's a bit bigger. And we don't need this here. This should be fine. Let's say you want to write a new file implementation that is a read-write closer. It then just spits out 3 implementations with the red message signature, which all just panic.
Oh, that's sick.
Yeah. So you get started quickly, and then it yells at you once you try using it.
And it works with custom types as well, it looks like.
Yeah.
As you just did it with margaret log.
Yeah, I think it should be right. Yeah, yeah. If it can find these, then it will do the thing.
That's really nice.
And then
copy pasta king.
Yeah, and then it does nothing. Let me think twice what the trick was.
Magic test structure.
Yeah. What we need to do now here is basically register our test thing here. And then it panics.
Nice.
And when we, yeah, because get is not implemented, of course. So, yeah, we have this corpus thing. Let me quickly start checking the stuff in so it doesn't go super baloney.
Yeah, that makes sense. Kind of having a more incremental look at the log afterwards.
Yeah.
The commit log.
These are
Margaret log.
just some. Yeah. Just have these three start. Skeleton for flat log. Yeah, and these can all go. These can also go.
That question mark was like so reminiscent of like Windows 95 or something. Like Windows XP.
The file name, yeah.
No, like the question icon there when you were deleting.
Yeah. Yeah, right. Yeah. The pop-up thing. Yeah. So we now have nothing. So we have the four methods that we need to implement, which is sequence, get, query, and append. And now we need to decide how to do this, basically. So to start simple, I will start with it because we're using a flat file. I will just embed the file itself here. Should probably be a pointer. And then we open the file. We should probably use open file because then we tune with flags how it's reacting to an existing file. But for the time being, I will just like table-driven test style. I will just do the most simple thing and then later tweak it to do the expected things. So for instance, one issue I already think about how we will do this is the concept of a sequence. How do you know the line of a file? Like files don't have lines. You have to count new lines basically to find them. And then you also need to make sure that your entries don't have new lines.
Yeah, I was thinking about that as well. Like that part's a bit shitty, right?
Yeah, I mean, this will never be a real implementation, I would say. It's just more to the demo purposes of how these interfaces work, I would say.
Yeah. Well, I mean, might as well try to make it as real as possible, and if someone uses it, then hey, that's cool. Without going mad in the process. What?
That's your part then, though, because I've seen.
Yeah, for sure.
I mean, yeah, like the encoding of the entries in a way that they don't have new lines, for instance, that would be a good thing to go about. But yeah, we will go there, get there. So now we have a writer, which means that we can write to stuff. So let's just do that for once. So in the append thing, we're using the writer, and we're turning the value. What are we doing?
So the value is, what's the format there that we're getting back?
Right. So what we are getting passed into is the type that gets appended. So this, in the simple case, these are just integers. So to stick with the table-driven test, and maybe we add strings to the simple thing, and we could, for instance, could see how this works
with the new line problem.
Yeah, with some other complex types, for instance. But for the time being, I will do this here, which is make sure that's an integer value.
Wait, So do you always have to do that like OK thing?
If you leave it out, it will panic at runtime, and you have no chance to handle the error.
Even if it's okay? Because I've never gotten a compiler, like a type assertion, to actually work. I just write them and then I'm like, fuck it, I'll just do a type conversion instead. Like, I don't know if you have to do that part or not. Like the OK.
Well, you don't have to do it if you know all the code paths and that nothing passes in a wrong value.
Yeah. Well, I'll see how you do it. Like, why it hasn't worked for me previously.
And this is, of course, pretty similar to what I said earlier. This is definitely a hairy and bad smell of this whole architecture, because it slows down the whole system immensely, because the runtime always stops and has to look somewhere else if the types are correct, and then keep doing its thing.
You mean with interface?
Yeah.
Type,
yeah. Every time you have an interface, it has to box and unbox that and ask the runtime for the type information, and then it goes on doing its thing. So I'm using filmed print line because it's super simple.
Yeah.
And then we just write the integer value, and we get a new line for free. Isn't that nice?
Look at that. This is amazing. Who would not want to use this? No problem.
So another issue now is that the append thing expects us to return the sequence number of the new entry. So how do we get that?
The length of the file?
The filmed thing will just return. Yeah, but how do you know? Like if I write large integers, what I basically propose of doing is just to keep the count and reestablish this when we open the file. So for that...
So in the struct then, or?
Yeah, in the struct, yeah, basically current sequence. So let's make a small utility thing, which is count lines from a file. Yeah, why not from a file? Yeah. Doing this in a rather messy way, or yeah, I will do this in the most messy way I can think of.
Nice. Just throw the spaghetti in the fan or whatever.
This, of course, will yield the full file into your RAM, which, depending on how large this file is, could be kind of big. So this is basically already where the offset file starts to shine, is that you just need to look at the end of the file, or the end of the helper files, and then you get the length of the number of entries in the log. And then there is strings count. Yeah.
I mean, I guess we could do a similar thing here. We could just remake offsetlog. Oh yeah, what could go wrong with line 34? Absolutely nothing.
Yeah, exactly.
Especially not if you're writing from like Windows. I guess it would work still.
Yeah. So lines, error, count lines, the file writer. And what we also need to do is, now that we read this thing to the end, we need to reset it to like scroll it back to the beginning. Seek, yeah. There's actually, I think there's constants for this in OS.
Oh, look at that fancy parameter name.
Whence? Yeah. From where? You can to the current position or current and set. I think set is the IO seek start. Yeah, these are much nicer, I think.
Oh yeah, that makes way more sense.
Yeah. Copy.
What's the first argument then?
To which position you seek. So you can say seek to the 23rd byte from the start.
And why do we have seek start then? I thought that's what I was doing.
That's relative from where.
I see.
You can have seek current, which is the current cursor position, and you can like seek 23 from there, plus and minus.
Yes.
From the end. Yeah. This should probably do something with that. So in this case,
put it on the file.
Do the current sequence directly. Oh, and then this should probably error out. Otherwise, we just shadow the error, which is not nice. Oh yeah, and what I'm also starting to see. Let's see if we can produce an error where this is an issue. But yeah, now that we have our nice thing, we can start returning sequences, for instance. And we could also, we can use get yet. We need to have a trick for that too. What I would probably do is return. Current sequence +1. So once we wrote an entry and we didn't run into an error, which is also important here, like that this could be full or whatever. And then I'm not doing the observable yet. And what I also noticed is that if we, like this doesn't work, and this probably, no, that's not what the thing is complaining about. But since this isn't a pointer, this would do nothing, or not what we expect to. It just changes this thing in this scope, and then when you return, since you just work on a copy here, you have to do this. And for this to be meaningful, we have to return a pointer here, and then we can return null here, and then return a pointer here. Oops, nope. So now it doesn't panic, which is nice, but it fails totally on everything. And yeah, okay. So in each case, it fails to open for no such file reason, which is what open does. Because if open, you have to try to open a file that's not there. So we can do create, and this is basically coming back to what I said earlier. If we need to use open file here, basically, and then control the flag, which is OS create and OS not truncate. Create's fine. And then I was gonna append. No. Right. That makes sense, but since we always read it full in once and then seek it to the beginning, the append options don't have to do. I think what we do need is OS RV. Read and write, yeah. So, and another thing we need to do, we need to create the folder the file should be in. And for that we have file path there of the path. And also just for the owner of the process. Is more than one arrow? No.
File path? What the fuck?
A file path, similar to the path and node thing, this abstracts for you if the system uses backslashes or front slashes, like Windows or Linux systems. And then we don't need this anymore. We should probably annotate these errors if this is going to use a real implementation. Oh. Everything still fails.
Expected 0, actual 1.
Get case 0. Let's look at get test again. Get test 41. Ah, yeah, right. You start with 0 lines, and so the first time you add something to it, right? Yeah, I forgot that. Good to come across it again.
The sequence numbers are 1 indexed here instead of 0 indexed.
Yeah. So this count is probably also off by 1. So an empty file should have -1 now. This is getting a bit weird. Let's see if I remember this right. So it's 0 here. And then maybe let's do this for fun. Maybe profit. Maybe do simple. Yeah, okay, now it's not so super noisy and
thank God.
50 tests at once.
Open with 0.
Even though I did a -1 here. So why is there 1 counted there already?
Have you written to it or what?
This is just when we open it.
But we open it as create or read write.
But it should still be an empty file, right? There should be no new lines in there. Or am I?
I don't know. I mean, did we run appends? And because we don't delete it either.
Okay. This is before. Ah!
But you ran it previously with other tests.
Yes, what I'm not sure about, but I'm really sure about is that it removes the test run folder for us.
Okay. Looks empty.
2 bytes actually.
Wait, is that the file or?
Yeah. Wait a second.
Shit.
Was it this? Yeah.
Let's write down hexil. I was trying to do some like hex dumping shit when I was looking at the offset log, and it sucked shit to do it in Vim. Oh, that's nice.
Yeah, and so this definitely is a new file. I was just wondering that. Let's look at this simple test again. Up implementation. Yeah, I wanted to drop the body here, but that's not needed. Yeah, okay, this doesn't clean up because
it's still open, or
no, there's this test helper thing here, and expects the log to have a file name, which is then used to remove it. I've never seen this before, but apparently it's a thing.
Okay. So it's technically part of the interface then, or?
Some people call these interface upgrades, that methods have other methods that the interface doesn't need. So this is an inline interface. This is pretty bad, but it's this type assertion thing again, right?
Yeah. Fucking, I've never seen that before. Cool.
Yeah, it's well, you know, like you could pull this somewhere in a type definition and then. So to make the test happy real quick. And then we just return write a name. Yeah, now the error is gone. For the last run it got a 2 even. Now it's not complaining about the delete anymore because it's deleted after the run. So just to be extra sure, let's delete all of them. Still the first entry is wrong.
Why?
Yeah. I removed the -1. Why did I do that? Why did I do that?
Why?
So you see, now we get a panic again. And yeah, it's opened with -1 as expected.
Because we're going on to another test that's not implemented then, or?
Yeah, it now gets past that step. And the next step after appending all the entries, is creating a query spec. Which then, I think we should focus on the get test to not make this super confusing how to implement a query spec actually.
Yeah, I think so too.
So let's focus on the get test, which we can do by just using get here, I think. Yeah.
Bueno.
So back to the implementation. Get is not implemented yet. So how should it do that? So
this means we want to get one of the lines in the file.
Yeah. So how do you get the line from the file?
You just iterate until you get the sequence number, and then you just return it. Efficient.
Super efficient, right? Come to think of it, sadly, as far as I know, at least, there is no way to profile I/O reading. You know, like this could be super interesting actually to show the benefits you get from these offset files, basically.
Yeah.
What I would do here is the most gruesome way, which is similar to what I did here, which is read all the things split by line, or you could, let's not do it super bad. Let's do what you suggested, which is stick the file back to the beginning. Oh, yeah, this is going to be iffy because if you like append one, then get one, and append again, of course you need to seek back to the end, right?
Yeah. So I was thinking, like, if we have a sequence that's greater than our previous position, then we have to reset. Otherwise, we can just continue. Like, if you get 1 and then you get 2 and then you get 3, there's no reason why you should have to seek back to 0. This is great.
I will leave this open for you toying around with.
Okay.
In theory, I agree, but it just makes the code more cumbersome right now.
Yeah.
So was it start or was it seek? I think there was a seek thing for the current position also.
Nice. On IO then.
Yeah, I think so. Seek current. Oh, there's no help. Nice help test on this.
Sequence values. Brave tonight.
And then later we return it. If I remember correctly, these are then returned. Let's see. It returns the new offset and an error. Yeah, so you can use that later to seek there again. So now in between, we are at the beginning of the file.
Beginning of the line, or?
And later, jump back to where we were. What I'm using now is a utility from the buff.io package. Not sure if you used that before.
Yeah, but not super thoroughly yet.
New scanner is kind of nice for new line-based files. It gives you a reader thing that you can just ask for the next line, the next line, the next line.
Nice.
So this is basically exactly what we want.
Very Python.
And the scanner has a bunch of methods. One of that is scan, which basically scans to the next line.
Yeah, no, I think I've used that.
And now we basically...
And then it scans into a token.
Sorry, what?
Does it scan into a token as well, or?
There's another reader thing, I think, where you can say what your token is.
Okay.
But this one is for new lines.
Okay, yeah, I meant like it scans into a variable, but maybe not. That you predefine. Yeah, just keep going.
Yeah, so this gives us the complete line, and I would just say our I is the sequence thing, and and then we just count the I down until we hit 0, and then that's our line.
Great.
Right? Now don't make it off by 1, so do we increment before or after? So
you wrote out instead of our.
Yeah. So, and now of course, if I is smaller than 0, Margaret out of bounds. Also, scanner can error, so it might just, not sure what the actual errors here were, but for instance, you could also, since this just accepts a reader, you could do this with a network connection, like and the network connection could randomly stop working. Or you do this from a USB stick and that fails, and that's why you have an error which tells you if something went terribly bad. Just for real quickness, the starting value is now jumbled, but we can do the sequence again to get it again. No, we didn't return anything, but let's just do this a lot. I just return to do, and then I see if I get the to do error. We found line 0, and it's empty. This is nice. Another cool trick is Q. Not sure if you've seen Q before. Q gives you a quoted string, which escapes all the values and gives you quotes around it too.
Oh, nice.
So I feel like we have an off by 1 error because we get an empty line back, and this is of course not what we want. I'm sure I'm off by wanting everything here. So let's see. This is also peculiar since there is no file.
So I didn't get the seek current part at the start of the get function.
Wait a second. Just wondering where it's writing to. What do you mean? This here?
Yeah, exactly. Why is it not seek start?
Seek start would seek to the beginning of the. Thank you. Thank you. This is just jumping back later, but we also need to seek to the beginning to have the reader go from the beginning. Yeah. If we seek to the beginning directly, we get 0 here, and we don't know where to jump back to.
And we want to jump back to so we can append later. Okay, that makes sense.
Yes. This is double. Yeah, and now we find our 1. This is what we actually wrote to the file. Isn't that nice? Sure. And then we're finding line number 1, line number 0. So these are off by 1 again, of course. If we want to keep in the length, yeah. Cool. Yeah. So what we also should see now is
what's that little quick?
This bleep? Yeah, that's if the thing can't complete. Cool that this is also in the recording. Nice.
Wait, if like you're typing something and it can't complete?
Yeah. If I try to complete something and nothing is there.
Oh my god, I would die. Is that what you like have to go to the bathroom if you do too many errors? It's like a little droplet and like, oh shit.
Yeah, it's a very Pavlov thing maybe.
Yeah. But yeah, sorry.
So yeah, okay. Error. The odd thing here. Wondering how to work around this. So the way the test is set up, that if yeah, let's do this differently and just delete. I think this is an old pattern.
Okay.
So it deletes the test run after it, and of course, then you don't see what went wrong. What I prefer doing is delete the file before the test runs, and then afterwards you have the.
You can inspect it.
Yeah. But how? I mean, this doesn't work because it just works after the. Yeah. Okay. Then just to not break. Yeah, this has to be reset then later. I will just leave this here so that I know. But I feel like the better way to go about this is to just remove this here in the beginning. What we use as name is the path. Yeah, and then we still have our file, which in this case is 0, which...
Look at that beautiful log.
Look at that.
Margaret would be proud.
And 0A is new line.
Whoa.
Isn't that awesome?
What could go wrong? I see no issues.
Yeah, but for instance, what we can do now here is that
Oh.
Oops. Unexpected type string, which is, of course, what we told it to do.
Where do you see that error? At the bottom?
Here.
Okay.
Sorry, yeah. Here, and so yeah, these first are the ints still, and then it goes on to the next test. And what it should do here, maybe. Yeah, this could be fun. Let's see if we can make this. And we don't need this integer here. Oh, s_f. Yeah, and now we have not just the indexes,
Cool.
but we have the
typo test.
Yeah. Yeah. Oh, let me quiet you down. So, yeah, to fix this real quick, I will change this thing into a different thing.
Yeah.
So we use
type switch statement.
Yeah. And then we have the type value and int here, and we have a string here. And to write the string, we make it like this maybe, and then we just write exactly what we get. And in this case, we use string convert format int. In base 10, I guess, is fine. And then here we write our out value with the new line by from current line. So why do you... Yeah, this is a bit iffy because you can't have fall through in type things.
No, yeah, because I was just wondering about like if int would also match 64 and 8 or whatever.
I to A, right? Yeah. Let's see, does this work? No, this one needs the other one, yeah. And now, yeah, we found our line A, B, and C. Whoop. So where it's faltering at, oh yeah, it's this thing. So the most gruesome thing about all of this is also now that we don't know what to return the values back out of. Do you know what I mean? Since the encoding basically flattens, the writing flattens the encoding, we don't know if we should return an int or a string here. If you get the value, you just have bytes which don't tell you, was this the string with a 1 inside, or is this the integer 1?
Yes.
So this is really bad. So something like JSON could at least tell you that this was a 1 and this was the string 1. Actually not sure how I would get around this time other than using an encoding, which is a proper binary encoding. For instance, there also is go-ssb. Not sure if you've seen that before.
I think you've linked it.
Could be. That way we might also get around the new lines, but I haven't used go-ssb. I haven't looked at go-ssb actually anywhere before.
The thing I was thinking of, now I hear myself suddenly.
Is the back channel canceling starting to break?
Wait, no, worked. Test. Yeah, okay. I think it's fine.
Just 1 second. Okay.
Okay. Yeah, I mean, what I was thinking was that Well, I was just thinking of it from a SSB perspective. So each line was just the entire JSON, basically.
Yeah.
Yeah,
and then you don't need it as much. Yeah.
Yeah. But of course, so I mean, in that sense, everything's just a string.
Yeah. If that's fine, for instance, then this could be totally fine. But of course, if you try to do this with all kinds of all kinds of types, then you get into these kinds of problems. For now, honestly, to keep this simple, I would just ignore the in case, for instance, and then we just return the strings that we get. So now we here just have to return our line, probably without the new line. The new line? Yeah, the new line is already stripped by this. Otherwise, you would see the \n in our little debug prints here.
Yes, because we just Wait, what? Don't we see it?
No, we don't see it. It's gone. It's returned
you
by
have
the
a new line
scanner.
there. Okay, cool.
Yeah, right. The new line. Yeah. Not so quick. Okay. Pass.
Wow.
Ship it.
Dominic, we're coming for you.
Yeah.
Maybe okay, so what happens if we actually have something interesting as the test case? Or do you don't want to handle that?
Wait a second, what?
Hello, new line world.
What do you want? We can do everything here.
Yeah, okay. If we next test is strings, but instead of ABC, we have A, and then instead of B, we have hello, new line world.
To produce something problematic.
Expected complete gobshite. Oh no. Wait. What?
Wait a second. I also
is expected reversed.
Something I should have included here still is just make it more make clear which is which. Yeah.
This was probably just in the test.
Well, it's doing exactly what we want, or what we told it to, rather. So we haven't escaped anything. So of course the new line is in there and everything gets mumbled by one.
Yeah, no, I was just, I guess, confused by expected hello actual. Was hello n world. It should be reversed,
those right? Probably need to be reversed.
Yeah, it's there, 51.
Here, yes. Now we have the get and want thing again. So these are the ones here. And yeah, I've done this so much. I mean...
Yeah, and because like I think tape has the reversed as well. It's really confusing.
Oh god, yeah. There's no right way to do this. Yeah, exactly.
Yep.
Yeah,
that's what I expected as well.
Yeah, right. So, I mean, one way of going about this could be, for instance, to base encode everything, because, wow. Raw is fine for this. I mean, you could find another way, but I mean, if it's just, you basically just have to replace the new lines with something that is never in a string. But what's never in a string? I mean, this, of course, makes the files like 35% larger, which is also nice, I guess.
Yeah, I'm curious to see what the output will look like. So everything is just going to be base 64, or is only the new line going to be base 64?
No, everything is base 64.
We're like, you have a flat file, it's nice and expectable, Now we make it shit.
Yes. I mean, if you have some magic bytes that are never in a string,
Yeah.
that works too. Or, yeah, that's interesting. That could work. You could have, as the first byte of each line, you have the replacement byte for the new line.
Mm-hmm. Nice. Interesting.
It's at least one way of going about it. Yeah, storing some metadata there. I wonder. Then, of course, you have to look.
I mean, it would be nicer maybe to put it right before the new line. I don't know.
Yeah. Before the new line at the end, or what do you mean?
Yeah, exactly. I don't know if that makes sense.
That also works, I guess. I'm relatively sure it works. Let's see. So let's start with something atrocious and then make it better. So I mean, yeah, this just skips around the problem by making it a different problem, but let's do maybe, I have no idea what's not really used. Maybe,
ASCII table, like.
Yeah, look at the ASCII table and find something that's...
I mean, there are tons of things there in the beginning, like maybe a bell.
That's /b, right? Or what's the code?
Yeah, it's 7.
07, yeah. Yeah, that works.
Because then when you cat it, like in some terminals, it'll just go bing, bing, bing. That's so good.
No, value old is new line, and new is new line replace. Yeah, and then you would just do something here like strings index. Index finds indexes in the string, and so if is not -1, so if was found, then we just return with an error, and then later we can be like, okay, find an actual replacement, or find a function that finds something that's not in the string. So if you have a string with every character in the world, then you have a problem.
Yeah.
Repulse. So what we do now need to also do now, of course, is put in at the end of the thing I will do it like this, I think. Oops, yeah, not like this. I can also do it like this. Oh, and then we need to move this out there. Yeah, we can write 2 bytes. I think this is fine. So now, of course, we need to revert our replacement thing. And
I mean, like, really, like, if you just have a problem because you want to type a bell character, then we can just replace the bell character with something else.
Yeah, exactly. I would use some kind of iterate over this, do the lookup thing, check the thing it's not there, and then use that.
And then if you have something else that you want to write, we can just replace that with something else.
Just file an issue. Wow. Okay, so
I might have been joking slightly.
okay, yeah. Then I'm not at the right.
Okay.
Does
your terminal have a bell sound?
We will find out in a minute or two.
Oh, exciting. Okay, yeah, sorry.
No, yeah, this should be call line. And now strings replace all of our line.
Yeah, you're converting it back to sensible land.
Yeah.
Okay.
Oops.
How dare
I messed something up. I messed this up.
Thing.
It should stop. I just got the end out, which is really yes. Ta-da!
Exciting.
And now, if we get the file,
I think this is a feature. I mean, this is great.
Yeah.
Although there's a colon at the end of everything.
Then it's off by 1 still.
I guess you don't have to write the colon, or...
There's more belts now. It's too fast, but there's definitely more belts.
What's that SNL sketch?
Like, I guess so.
Needs more bells. Yeah, I think this is like going to be the new log format, to be honest.
I think it's also broken because I'm not sure what it...
I mean, you're just...
yeah, no, this has only belts, right. Of course, this doesn't show me. Yeah. Right, so let's see. I'm confused. What did I want to do?
Nah, it doesn't really matter.
This is right to have the colons because it's the embedded file which has the replacement byte at the end.
Yeah, but I mean, if you know where the replacement byte is, you don't have to have the colon.
Yeah. I see what you mean. You can spare another byte of this.
Yeah. And also the aesthetics of looking at your files, man.
They have a weird character at the end, and that's much more usable, right?
Well, it makes a sound.
Sometimes it makes a sound. I mean, right now it always makes a sound. But
yeah.
It could be any other.
I wonder what would happen if you had like a pager and you're just like scrolling through a really long log. If it would like blip, blip, blip.
Probably.
Amazing.
And I'm confused. Wait a second. Why did this work? Is it now like this? Confused. Yeah, now it's doing something totally wrong. I think it replaces empty line with empty string with lines, but it's not 2 now. It's still the last. Yeah, that makes sense. Yeah, sorry.
Yeah, cool.
Yeah. Okay.
This is so good.
We now have something like a thing. Yeah, what's missing now is wiring up this observable thing and being able to construct queries in a way that makes sense. Yeah, let's maybe commit this real quick so that
add more bells.
Yeah, what's missing? More bells.
Yeah. Maybe this is the flat bell format. I don't know. The cowbell format.
Oh, that could make sense. Yeah, okay.
Yours was pretty musical. Do you think they would like this format?
Ooh, I mean, if it used MIDI maybe for the thing, and then you could play different notes.
Oh wow!
Yeah. Pew, 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 pew. Oh shit! Okay. Status, yeah. So, should we look at some actual offset formats, or do you want to keep going with this?
No, I think that was perfect. This was a really good start.
Yeah.
And it's at the nice level of complexity where I can just look at it very quickly and be like, oh yeah, this is what you do.
Yeah, let me push this before I forget that part.
Yeah. Was that the log? Or? I want to imagine that some computer at like GitHub's like main data center now will blip as well. Like.
Yeah.
Maybe if you run the test.
Bell protocol.
Yeah.
Perfect. Yeah. Let me recap. Think real quick how to go about this now. How late is it now? We are at 11.
I'm all right so far. Maybe in 20 minutes I'll be dying from hunger. Who knows?
Or we take a quick break and then resume after lunch.
Yeah, what do you want to show?
I would go into a bit into how the byte format looks like.
Of offset 2?
Yeah. And then maybe start a simple reader.
Okay, cool. What would be the idea for the simple reader? Like why?
To be able to iterate a Dominic offset file, basically.
Oh, so not a reader for offset 2, but a reader for offset
Dominic. Offset. Yeah. Yes. Yeah, for offset 2, everything is there.
Yeah, because otherwise I'm like, how are you using it? Yeah, okay.
Yeah, right.
I think we're just like talking, using different words in the wrong way. Yeah.
Yeah.
So you wanted to show offset 2 and then look at doing the Dominic stuff.
Yeah.
Okay, cool.
Yeah. Right. Yeah, we can quickly look at how offset 2 works. Right. And then go to Dominic. Yeah. Makes sense?
Yep.
Cool. Then let's interlude here.
Yes.
Meow. Now to jump back into it, and like we said previously, I would briefly explain how offset 2 is working. Maybe show some of the code, but not too much.
Can we hex dump offset 2 file as well?
Yeah, that's what I wanted to do. These are just a pump test case. Okay, that's not super exciting. Get to test all again and go test run test log offset 2. Maybe JSON, that's easiest to look at. And then we go to test log offset 2 JSON simple. Right. This tests hide the test data again. So I will do the previous step of just uncommenting the cleanup function so that we get some actual log. Simple and comment out the cleanup thing. Now I'm in the folder. Get back this one. Now, and simple, there's actually folders with files. Okay.
Nice.
They all, we've shown the tests before. I would maybe look at that doesn't make much difference. We can look at the reverse, that has 5 entries. Oops.
That bell sound now.
Yeah. How dare am I to shut it off now? Okay, so right, I think somewhere where
Get was an easier one, or
Yeah, but we just need to look at the file format now.
Cool.
So to quickly jump through it, the definition is in the package, the Go-doc package definition up here. Let me see if I can wrap this.
Why are there new lines between each, or blank lines between each? Is that something with the format, or?
Yeah, it has something to do with the format. Yeah, if there's no blank lines, it would make it one paragraph, and then you don't have a listing thing.
Oh, really?
Yeah, it's a bit. Sometimes you need to double check what it is.
Yeah. Okay.
So these offset2 logs. These offset2 logs consist of 3 files: the data file, an offset file, and a journal file. And the data file is a list of length prefix data chunks. The size is UN64, so it's the size plus the number of bytes is the length of an entry, basically.
Okay, a list of length prefix data chunks. Okay.
Yeah. So each data chunk has the length of the data chunk in the beginning.
And then all the data.
Yes, exactly. So you can actually read it by just reading the data. You just read an UN64, and then the number of bytes, and the next, and the next, and the next. And so if you do this here with the hexadecimal data.
What is this?
So this is the very boring one, of course. Can probably add the test we did before with the ABC stuff and show that too. But right now we just see 1, 2, 3, 4, 5, 6, 7, 8, 1 byte, and then the byte, and then another, and then the next byte, 2, always 1 byte long. These are, like I said, this is the most boring one you could think of. So maybe let's do what we did before with the get thing. Yeah, here. Ta-da. Trick 17. Now we have our nice strings here again.
Lovely.
Need to get back here real quick and run the go tests for get. Oops, no. Oops. Yeah, run all of them. Why not? Whoosh. Sorry. No, this is right. Type 1. And if we now do a hex of data, now we have a bit more exciting data. So the first entry now is 3 bytes long. And then we have a 22, a 61, and a 22, which translates to quote, a quote. And then the next entry is 0E, which is 15 bytes, I think, right? Yeah, and then you have the hello world, and you have the quoted, you have the quotes in the beginning again, since it's marshaled as a string.
Okay, I was something
in JSON. Yeah, this is in JSON encoding.
Okay, cool.
Okay. Right. So this is the data file.
Nice.
And if we look again now in the format definition, the offset file is just a list of UN64s representing the entries offsets in the data file. So if we look at hexadecimal offset for the same entry.
So each of these, the items in here will point to like A, and then the other will be hello world, like the byte offset.
Yeah. So it's the beginning of the data entry. So the first thing you read from the data file is the lengths, and then you know how many bytes to read. So the first one is always zeros, of course, which was the first entry starts at 0. And then the next entry is 0B, which 8, 10, 11. So 8, 9, 10, 11. Yeah. So this is where the next entry starts, and so on and so forth.
Okay, cool. Yeah.
And the journal file is just there for a consistency check, and it contains the number of entries in UN64. So we have off by 1, not off by 1 by 0 index, so it has 3 entries right now.
Wait, so that's like the latest sequence number in a sense?
Yes, exactly. And every time you open a log, you check the length of the number. You can basically divide the offset file by 8 in bytes, and then they have to align, basically.
Yeah. Okay.
Yeah. Maybe to make this a little bit more interesting, just to see it at once, I can open my. Can I? No.
It shakes whenever I see someone just like ad hoc DD. Like, oh,
where are you going with this? No,
don't
I just wanted
destroy
to
your
show.
Computer.
Count byte size in whatever 8. Count 10 of that. So this is now the first 10 entries in the go-ssb installation, the offset file. And we can do the same thing. This is of course not enough, but let's see. Yeah, that's it. Just some more. Oh yeah, you have to ignore this stuff. That's of course annoying. Now it's better.
Hello world.
Hello. Yeah, this is a bit more exciting. So the length is much longer, of course. And then you have some CBOR data, and then somewhere in there it starts with the actual SSB payload.
So it mixes inputs, or why does it have CBOR and also JSON?
Yeah, I can get into that later, but the encoder of the go-ssb installation uses the the header, so to speak, of a message is in binary, and it just keeps the original payload around because I don't want to re-encode it.
Because of the hellishness of the canonical whatever.
Yeah, I don't want to reproduce it from.
So what's the header?
Wrong. The header is the author, the message hash, everything that's not in the content. Yeah. Okay. So, yeah. I mean, yeah, the sequence, the author is again in here, but yeah, you have to send this around, and the signature is on the bottom here. Yeah. Okay. So if we get a bit more of these, then here's the signature, and then it ends, and then the next entry starts, and then it just goes on and on and on like this. So if we, for instance, let's do this in all of them. This is probably not at all usable. It will end in a minute or two, or not. This was dumb. What was it? Seek? I think there was something like Seek. Oh, that was too large, I think. Are you still there?
Yeah, sorry.
Okay. Yeah.
I was drinking and didn't want to like gulp.
Okay. I just was wondering if something happened to the connection again.
Oh no, it works.
Okay, seek doesn't work like I thought it would. I just wanted to show the end of a file basically, but I'm too dumb to do this right now. Yeah. So maybe we just look at all the offset. Yeah. This is quite a large file. I think it has like 1.5 million entries in it or something like that.
Damn.
Yeah. So
what do you use this for? This like feed, I guess, the log here.
This is the offset log of the full bot. So it has all the feeds, and yeah, it's the main data store. Just like with the JavaScript stack. The only difference basically is that it keeps the offset separately, and this means that you can work with normal indexes like an array would. The offset of Dominic always just works with the offsets. So you don't like have entry 1, entry 2, entry 3. You have offset 0, offset 25, offset 625, and so on and so forth. So you have like lots of missing entries in between, so to speak, or not missing entries, but the numbers get large rather quickly. Yeah, I just wanted to show that the end of the offset, of course, then is rather big, but the difference between them is basically the size. Not that that's used for anything. I just wanted to show they all keep this same pattern, and you just have to work with multiples of this UN64 stuff.
All
right.
But this specific like log file that's under .ssb-go, is that for your pub? Is that for like the Oasis identity you play with, or what?
Right. This is yet another strange cryptics. This is the LTQ3, and I have...
The fuck's that?
Yeah, it's one of my 5 sub-identities or something like that.
Okay.
I don't have more of them. And this is on my desktop, and I have used it with Oasis, but I don't post on it that much, but I have it around to sync my other devices with, basically.
Okay, cool.
Yeah. Right, but yeah, just maybe to finish this chapter off here. So to read entry number 5 from the offset log, you do the following. You seek to 5 times the size of a UN64, which is 8. So you seek to byte number 40, and then you read the offset thing. So the this is
the index for where it's at in data.
Yeah. So byte size is 8 bytes. So now I read 5 of... Oh, no, this is data, sorry. Offset. So the final thing here would be 0899C. So in hexadecimal, 9C. Oh God, I haven't done this in ages. By hand, at least.
Yeah.
So 16 times this plus 9C. Yeah. To that size, and then to that size you open the data file, you seek to that, you read the length of the entry, and then you read the entry. Yes. Yeah, and all UN64s are in big Endian.
So step 1, do you have to do that calculation yourself, or is that done by Margaret?
No, this is all done by Margaret. We can maybe now look at the actual implementation real quick. So let's see where the open is. This is where the open is. So, and now you open 3 files, basically. You open the data file, you open the offset file, and you open the journal file.
Yeah, wait a minute. Don't scroll so fast.
No.
Okay, now it's starting to blur less.
Oh, shit. Yeah, okay. Yeah, like I said, you have these are all stored in a folder, and then you have these 3 separate files.
Yep.
And then you construct the offset log type and assign the journal and the offset in the data file implementation. These are then implemented in data, journal, and offset. There's a check function. The broadcast for this changing sequence thing we talked about earlier is registered. Get the current sequence.
For the observer, or?
Yeah, right. The observable, broadcast is an observable.
Okay.
Right. Or rather, here's the new observable with the starting value. Right, these broadcasts are used to update the live queries.
Oh, okay.
Yeah. The end. This is assigning the current sequence thing. So at the end, it seeks to the... Right, like I said earlier, it seeks to the end of the offset file, so getting the size of the offset file, basically. And then dividing that by 8 and -1, then is the numbers of entries in that. And so let's go to get. Okay, this is super boring, but we go to... Okay, no, the read frame is after that. That's cool. So the algorithm, or not algorithm, but what the documentation said is basically done in 2 steps here. Read the offset for the sequence from the offset file, and then read the frame from the data cell for that offset. So in offset read frame, offset read offset, this is done here. So you multiply.
And the frame is basically just the entire offset plus data, or?
We can check in a second, but I think it's just actually the data without the length.
Okay.
don't need to look at that anymore.
So it's a payload.
Yeah, right, exactly. Yeah, the frame would probably be that plus the length. That makes sense. Yeah. Yeah, so the read offset is just divided by multiplied by 8, and it's seeked there, and then you use binary read, which can read into all kinds of stuff. Tell it that it's big endian and marshal the int64. We need to update a lot of documentation because it's actually int64, it's not uint64. I just noticed this. Yeah, I know why. Okay, this might come back to us later, but yes. There's a helper for read last frame, and here you also see the append function, which is seek to the end and write the next offset. Back to the offset, and now looking at the read frame function, which you just passed the offset to. Yeah. Sectioned reader is kind of interesting because you can give it a reader and then just tell it from which offset and how much it can read. And then you can do read full or whatever, and it reads just the number of bytes and then gives you end of file once it's empty.
Oh, nice.
Yeah.
So once that offset basically has been, or the entire interval has been done.
Yeah.
Cool.
Yeah. So it reads at the beginning, it reads the size, and then it creates a new sectioned reader from the offset, so after the length and then the size of the entry. Yeah.
Yes.
Yeah, and then points the file directly there, and you don't have to seek around manually and all that. This is the manual seeking, so to speak. Frame reader, get frame, read frame into data. Yeah, there's some utility functions, but yeah, and the writing part is also seek to the end of the file, write the length, and then write all the data. Yeah. So that's it for get, basically. So now that we looked at this, I'm wondering what would you be interested in next?
I don't know. It's kind of hard to. I'm still kind of trying to understand all the functions we were looking at. If you go back to that last thing we were looking at.
The data?
Yeah. Okay. So append. So we get the offset. I guess I'm just like mixing up which functions are which functions. Okay. So we're getting the offset. Basically, how many bytes where we'll start writing to in the data. Okay. And that's the offset we want to write to the offset file, and we write that.
Yes, exactly.
There. Yeah, it's just D and O and all these are really hard to see.
You can make it larger if you want.
No, it's fine. It's just it gets a bit blurry. With encoding.
Yeah,
so it's hard to be quick. And then we're writing, but we're writing to. Where do we ever write the offset?
The data file. And this is we should probably jump to the append implementation of the log itself, or like the full log, and not the separate files. And then maybe it makes sense. Yeah. So the append file is here. So the first thing we do, we use the configured codec, which might be JSON or CBOR or whatever, or some other. I think in the go-ssb code, there's a custom codec function, basically. So this takes our interface value and then turns it into some bytes. And those bytes are then written to the files. So the first thing we do is increase the journal by 1. Bump is just increment by 1, basically, and rewrite.
Okay.
Yeah, right. And like you assumed, this is right. Rewrite the data to the offset file, which gives us the current offset, or where that entry begins.
And then we write the offset to the offset file.
Yeah. And then finally we return.
Check.
Yes, exactly. Yeah. And then we update this is the broadcast thing, which tells all the subscribed queries basically that there's now a new entry that they can consume, and the append returns the current sequence. Yeah.
Just have this like mental image of like a sad Luigi like pouring out a beer, like pouring one out for Tupac, man.
Yeah.
Yeah.
Okay.
Yeah, this makes sense, I think.
Cool. Without, I was wondering, going up a bit. To solve this query stuff, we have another type, which is this offset query thing, which gets configured similar to what you already suggested. This functional option thing is used to configure the query instance, and then it just reads through whatever it is. So by default, it has no limit, and then these query options configure the sequence number and latest and smaller or greater. Maybe you can show this a little bit. It's not how to say.
Yeah, I think we saw it previously in the test, maybe when you were specifying reverse.
Right.
Example.
Yeah. Yeah. So these are basically the implementations that take care of all of that. Yeah, and here it looks rather simple. This is just the assignments of this is the start value, basically. The limit sets the limit, and for reverse it seeks to the last entry basically. And the next thing then, next is the function for the Luigi sources that you call, and then it returns you the value thing. Oh God, what can we ignore here? Yeah, this gets a bit gnarly, but it basically just each time you call it advances to the next thing. Yeah, I'm not going to do that now.
No.
But you're definitely right. This is too involved. This is definitely too involved. Yeah. Yeah. So
I guess like if you were to write the Dominic offset, like what more would we look at here in offset 2 to kind of get an understanding for that?
I just wanted to give you an idea how these implementations work right now.
Yeah.
Because I would copy some of the patterns and maybe think about if we even need the live mode, then we can probably skip a lot of the weird stuff. So just for the listeners or the readers or viewers tagging along, we want to make a reader for the old format that Kix never implemented, because this offset thing gives you smaller indexes, and so I don't think we will ever use it apart from
just
reading it.
An existing file.
Yeah, reading it, maybe writing it, but probably not have it open as an actual data store. So we don't need the live reading part, and we probably also don't need to read it backwards. Some of the complexities here are also from, if it's in reverse, then you need to decrease the sequences, and if it's in reverse and you have the last entry, and
yeah, of course.
There's lots of tricks in here to get this working correctly, or to have it so short. Yes, I think that's about it, what I wanted to show, at least. Yeah, and for instance, also, not sure I showed this. Yeah, I think this is fine. I'm not sure if I need to go into much more detail. Yeah. So let me think, where do I get an offset file from now? You can maybe do some searching together, because I'm not sure where this is actually outlined properly.
Maybe an offset file?
Yeah.
You could run npx as generate fixtures thing, for example. Like npx ssb fixtures -- authors 1 -- messages 100 or something.
Let's see, I have that here.
Yeah. So
probably.
Or you already have one in there, probably.
Also good idea. Yeah, let's just use this one.
What does the report say about it?
The report says probably 200,000. Yeah.
Oy. Nice.
Yeah, that should be more than enough. I would just look at the couple first. Just so that my terminal doesn't scream at me. Flume, log offset, byte size maybe 4 kilobytes. 16 kilobytes is how large a message is supposed to be. Larger. Limit and get the count. Yeah, let's get the first 20 or so.
Lovely.
Perfect. This definitely worked as I thought it would.
Very
Not bad
antsy.
at all. Yeah.
Was it -R?
Okay,
Parse
something.
antsy unless.
There was something went terribly wrong, but let's maybe do it like this. It's my less.
Yeah.
For some reason, it's my less.
-R.
S-R.
Ah.
You're a magician.
Boom!
Look
Suddenly.
at you.
Well, now I'm just waiting for the screen to refresh. Okay, I think this is cool. There we go.
Okay. So, at the start of this, what we already see is that there's some JSON here.
Yes.
And it starts with the key. So, compared to what my implementation is doing, it stores the whole message as the whole message.
Basically the same spec as format that you see in the protocol spec, right?
Yeah.
In various places.
Yeah.
And the 00 at the beginning there is like the offset, or what?
I guess this is the length already.
Okay, yeah.
Because
it's like a half
1b6, 1b6. I would guess 00. This should be. Can you see my cursor even in this mess?
Yep.
Yeah, this should be the second entry, right? Right. I think you already saw this. Like it has the length at the beginning and the end.
Yes, exactly. Yeah.
Yeah. So this
you
is
can
the
read
last.
backwards for some reason.
Yeah, this is the same length as this one at the beginning here.
So the next colored thing
this
is
one here. These 1, 2, 3, 4, 5. And then let's see if we can find the end of this. So it should be 1C something.
Yeah. I mean, it is kind of nice because then you have these like packet delimitations. You can kind of look at the info if you run the right command.
Yeah, I think the trick really here is just to be able to read it backwards.
Yeah.
So
yeah, that's what's said in the README.
Yeah.
But I guess there's nothing here then. Is there some special byte at the end then? Because I was confused about like the file length from the README.
What I'm starting to figure out right now is that I don't see. I mean, yeah, the offsets just come in like a higher level thing. You need to, while you parse it, you keep track of that.
What do you mean?
You can't jump to entry number 40 without knowing the length of all the other entries. You know what I mean? You need to churn through it and skip one by one.
Yeah, okay,
or entry 512 or whatever, then you need to read all the entries in before and skip the length and the length. You don't need to read
you create an index, basically, yeah.
Yeah, exactly.
But I was asking about like there was this special kind of offset somewhere that was like file length offset. I mean, it probably doesn't matter at all, but I was just confused about it.
I'm not sure what you're talking about. We should go to the...
Go to the repository. Yeah. Flumedb offset.
This one, right?
Probably. Waiting for the screen. There we go. Yes, so...
Format, this one?
File length there at the end, yeah. That was confusing the shit out of me.
Interesting. So I think this is just... Yeah, so it's the data When it's just you and yeah, okay, that must make sense probably, because when do you have entries that are larger than 4 kilobyte? Yeah, that makes sense. We can look at the here.
It's okay. It's lagging too much sometimes, so I don't see the mistakes. As long as you're fast enough. Is this entire file as well, or?
Yes.
Cool.
So I think the length is just at the end. The last entry is the length.
Okay. Yeah, because like that was the entire like spec I had to look at. I was like, oh, where is it? I can't find the file length.
I'm scrolling to the bottom right now. Less is taking a moment.
Yeah.
Probably use more or something
Do you do
like that.
Shift G or?
Yeah.
Yeah. Oh, wow.
How large is this thing anyhow? 100. Yeah. Okay.
Oh, yeah.
Well.
Big boy data. This is what we call big data.
Yeah. Okay. More didn't work as I thought it would. I think I will just let this run. What is that R again? Remind me.
It's like make ANSI pretty. I don't know what it actually stands for. I just know that you do /R, you get nice ANSI.
That's super interesting. Maybe I should have because I have these while this is scrolling on the other side.
Mm-hmm.
I don't have this anymore. Where did I put it?
Like a special alias that makes less more useful, or?
So it is. I have these, and they make some pages colorful, but I forgot what they are for. And there's some escaping stuff, and I'm not sure this is working as intended with this one.
Oh, okay.
I need to double check where I got this from. And perfect.
There we go.
There we go. Yeah, and at the bottom here, right, this one, are probably the 4 bytes are the entry before. Yeah.
Yes.
0021.
And then we have the file length.
And this is the file length. Yeah. I have no idea what the file length is for, but you just have to know that it's there. When you read it backwards, you skip this part. Maybe it's some kind of consistency check again, because you can get the size of the file from the file system, you know.
I don't know. Like, you just have to call New Zealand and be like, "Yo, Dom, what do I use the file length for?"
I guess so.
Maybe it's who knows. Yeah, I was like staring at this so hard, like,
Okay, and this it's mentioned nowhere.
I don't know. It's just there, okay.
Just deal with it.